we're going to be discussing igneous rocks and how we have different recipes for igneous rocks. And on the screen here are 4 igneous rocks that all are from a different recipe. So we're going to compare this to making something we can eat. I wouldn't recommend chomping on an igneous rock. So chocolate chip cookies are one of my favorites. So if we want to make our own homemade chocolate chip cookies, we need a recipe, and a good one at that. The main parts of a recipe, of course, are going to be the ingredients and the amounts of each. So we know we need flour, baking soda, salt, oil, different sugars, eggs, vanilla extract, almond extract, and of course chocolate chips. But we also need to know exactly how much of each in order for our recipe to work out. So we need 2½ cups of flour here, not 1. We need a cup of brown sugar and ½ a cup of white sugar, and so on. Not only do we need the ingredients, we need the directions. How do we put these ingredients together and in what order? So here we know how much we have to preheat our oven to, that we have to first stir together the dry ingredients and then the wet ingredients and so on, and how long to cook them for. So here we have the ingredients and the directions together. Now, in order to make an igneous rock, or any rock, we need ingredients too. And what are our ingredients for rocks? And of course, you should know those are minerals. And silicate minerals, ones that have silicon and oxygen, are rock formers on Earth. And here are some ones that you've seen in lab. And can you identify them anymore? So here is a glassy, non-metallic luster that fractures, and that is our quartz. This one is distinctive by color and the way it's cleaving. This is our potassium feldspar, bubble gum pink or salmon pink, depending on what you like. Another name for that is orthoclase. Plagioclase feldspar is another feldspar in igneous rocks. You can see some striations in this picture here on the left. And we have our flaky black Biotite Mica that cleaves into these papery sheets. Splintery Hornblende. And another name for that is Amphibole. We have blackish green Pyroxene, which also cleaves like Amphibole. And we have our green olivine here as well. So these are some basic igneous rock ingredients. So now we have our ingredients for our igneous rock. We need the directions too. And what are they? Well, there are rock cycle directions on page 6 of your Earth Science reference table. I've highlighted the important ones. So we can take any rock and it can melt, form a pool of liquid magma, and then solidify or turn into a solid, solidification to form an igneous rock. So our basic steps for an igneous rock are melting and solidification. And that's always there in your reference table for reference, if you forget. Now, just like chocolate chip cookies have more than one type of recipe to make it, like we're seeing pictured here, each igneous rock can have more than one recipe for it too. So each one's going to make a specific type of igneous rock, but it's not going to be exactly the same. So here is granite, an igneous rock, a famous countertop variety here. And what we can see is that there's minerals in this granite. We see that pink potassium feldspar, this glassy gray quartz. The white is Plagioclase feldspar, and the black is biotite or amphibole. Now here's another granite, and you're going to see some similarities, but there's also some differences that are clearly here, and we're going to discuss that. So how do these look the same and how do they look different? You should notice some color differences for sure. And that's because even though one is a granite and two is a granite, they are slightly different flavors of granite, which we're going to talk about in a moment here. But there are also some similarities too in terms of the minerals that are there as well. Okay, so all granites have some similarities and they may have some differences, but all granites are going to have some minerals and not others. And for example here, you'll never find the mineral olivine in granite. If it has olivine, it can't be granite. And just like you'll never find carrots in a chocolate chip cookie recipe. So page 6 of the reference table is going to allow us to know our ingredient list. So here's granite, and if I go down granite, potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole are the possible ingredients in a granite. And granite is a felsic rock. We can see on this side is felsic, granite's on the left side, because it contains these lighter colored minerals that are also lower density. And now we can make a particular recipe for granite. Anywhere in this box we can make a recipe for granite, but I've drawn a straight line down from the N in granite, and it cuts through all of these minerals. And what we can do with this is figure out approximately how much of each mineral is in the granite by making a copy of the scale on this page. So if you have a piece of scrap paper or an index card, you can reproduce the scale like when we've done things with map scale so that you have a movable scale over here. I've been able to copy one straight from this presentation, which makes it a little easier. But if you imagine walking along a tile floor here, along this line, you're going to notice we're going to cross over more of one type of tile than another. So we have a lot of quartz we crossed over, and a lot of plagioclase, but a lot less of our time walking is going to be over biotite and amphibole. So now immediately we know in this recipe, we have a sprinkling of biotite and amphibole, and more like cups, so to speak, of quartz, plagioclase, and potassium feldspar. But what I can do with my scrap paper is I can line it up as best as I can, and now I can see that for potassium feldspar there's about 20% making up this recipe. When you look at the little tick mark, of course, is 5%. If I go down here to quartz, you're going to see I have 5, 10, 15, 20, 25, 30, 35, about 40% quartz. So there's a lot of quartz in this granite. If I slide down to plagioclase, I'm seeing about 20% again. And then for our sprinklings here, biotite, looks like it's about 5, 10%, and amphibole is about the same. And I could list those in a little chart here. So sometimes questions make you have to figure out the exact percentages, but that's kind of rare. Usually you just have to know that there's more quartz in a sample of the granite than biotite, for example, and no olivine at all in the sample. Now we're going to take a look at another granite, and I've drawn another line straight down all the way on the right of the granite, so it no longer lines up at the end, it's almost out of the box. And the question is, how is this granite different from the previous one? How is it the same? Without even having a picture, you walk along this line in your mind, and you can see we have a sprinkling now of potassium feldspar. So the color is going to be affected of this granite. Looks like we have a little less quartz now. But now it looks like we're going to be walking a lot along this plagioclase and much more along the biotite and the amphibole. So our proportions have changed. And without going through the whole process of using the index card, I've just showed you that we have a lot less potassium feldspar, 5% versus 20% last time, a little bit less quartz, significantly more plagioclase feldspar, and more biotite and amphibole. So if we look at these two granites, we're going to notice a little more black in here than over here, and a lot less pink, of course. So these are two granites, different recipes, but many similar minerals in it. Now we're going to take a look at a rock, gabbro. And gabbro, you're going to notice, is on the other side of page 6. And it has a much different recipe than granite. So now gabbro is on the mafic side of the table, and these are the mafic minerals here on this side. So therefore, rocks that are mafic are darker because they have darker minerals, and they're also a lot higher in density. So everything you need is on this chart here. If it's mafic, it's darker in density. If it's felsic, it's lower in density, lighter in color. And if you look at this gabbro over here, we have a whole lot of pyroxene in it, which we did not have any at all in the granite. We have olivine now, which we didn't have in the granite either. So let's go back a step. Actually, we'll go back 2 steps here because I have my little card. And if we drag it along this line, we can clearly see how much pyroxene is here. And we said about 65%. But even if you didn't use the card, you know on a question on the test that this rock has a lot of pyroxene. Or if the question asks a rock has 65% pyroxene, we know we should be on this side of the table, not here. You can see we have a bit of plagioclase, but now look, we have olivine over here, which we did not have in granite. And again, we get a good sense that there's somewhere around 15% or so olivine. And you can look at the rock now. Gabbro is a mafic rock. It looks really dark. And it's hard to see individual minerals because all of them are dark. But you can also see there's a greenish tint here due to the pyroxene and the olivine. So we've already talked about this, that a gabbro is darker, higher density, and mafic, and the granite is lighter color, lower density, and felsic. So the reference table is a big help for this kind of question. Anything that's asking you about composition, density, and the minerals in it. So now we're going to take a look at 2 more rocks over here, peridotite and dunite. And here's peridotite and here's dunite over here, and their color already gives away they're going to be in the green mineral section of your reference table. So peridotite, you can see here, has a lot of olivine and some pyroxene. And what is especially interesting about dunite is it's a rock that is made up of only one mineral, olivine. So it's called a monomineralic rock. And that's not too common. So again, in many cases, you just need to use this to figure out the minerals in a certain rock and roughly how much percentage of each. Now, the last thing we're going to talk about before ending this part of the video is that we not only have granite on this side of the table, we have rhyolite and we have pegmatite, on this side too. So if they're all having these minerals over here, why do they have different names? And that's the focus of our next video.